Hello boys and girls, welcome to the Math Club. In this video, we're going to talk about estimating probability and how to find the relative frequency of each event. Question 3 says, the frequency table shows the patient outcomes in a study of a new eye treatment. A. Copy the table in your notebooks and then work out the total frequency. Now, let's take a look at the table. As you can see here, the table, we have 3 events. For each event, we have a frequency. First thing, he wants you to copy the table and then find the total frequency. Now, the total frequency, we're going to add these together. So, 75 plus 5 equals 80. And then 80 plus 20 equals 100. Very good. So, the answer is 100. 100. Good. Now, this is the total frequency. Next question, calculate the relative frequencies of each event. Now, we take a look at the frequencies here. These are the frequencies, and this is the total frequency. Now, to calculate the relative frequency, it's very easy. We just take the frequency and divide it on the total frequency. Now, first one here we have 75 over 100. Now, let's write it here, 75 over 100. Very good. You can write it like this, or you can write it 75 like this over 100. But because I don't have space, I have to write it this way, okay? Now, next one, we have 20 over 100. 20 over 100. Very good. Or divided by 100. And then the last one, we have 5 over 100. Very good. Now, like this, we found the relative frequencies for each event. Now, let's take a look at the question. A further 300 people received the treatment. How many would you expect to have improved eyesight? How many would you expect to have improved eyesight? Now, let's talk about this. Here we have improved or great improvement, and here we have slight improvement. Now, which one he's asking about? In the question, he said, how many would you expect to have improved eyesight? And because we have great improvement and slight improvement, we're going to work with both of them, right? We're going to add them together and then multiply the number that we get of the relative frequencies and then multiply it by 300, which is number of people. Now, let's take a look at this one. Okay, first things first, we take the relative frequencies here, we consider them as probabilities. They are the same as probabilities. For example, if you have any number of people, now any number of people, you can take this probability and multiply it by number of people to get how many did they have great improvements. Now he said, how many of them would you think will improve? Now we have great improvement and slight improvement. We're gonna take them together. Now the probability or the relative frequency of great improvement is this one. And then the relative frequency of slight improvement is this one. We're gonna take them, add them together like this. We will say 75 over 100 plus 20 over 100 equals 95. Good. 95 over 100. So basically speaking, it's 95%. Now, we take the 95% and then multiply it by 300. And this is how you'll answer this question. Now, 95%, let's take it, put it here, or 95, sorry, 95 over 100. Let's stick it here. Yes, 95 over 100. And multiply it by the number he gave you, which is 300. So it's going to be 300 here. And your answer will be the number of people who had improved, or the ones that we expect to be improved out of these 300. Now, to find this, basically, you have to simplify numbers together. 0 with a 0, 0 with a 0, and then you multiply the 95 by 3. Or you can do the whole thing in a calculator. Multiply 300 by 95 and then divide it on 100. Now let's do it with a calculator and then come back. So 95 multiplied by 300 and then divide by 100 equals 285. Now let's go back. So the answer is 285. 285. This is the number of people that we expect to have improvement out of 300 people. And this is the answer for question D. Now, let's take a look at the discussion here. Is your answer to part D likely to be the exact number of people whose eyesight improved? What do you think about that? Now, the question says the answer to part D, which is this one, is it the exact number of people whose eyesight improved? Basically, if we're talking about an experiment, it will be the exact number. Because this one here is an experiment for 100 people. But with the 300, we just took the relative frequency and multiplied the probability of this experiment with it. But we didn't do the experiment on the 300. So basically, it's like a probability of having this number, but it's not the exact number. And we will talk about this in the difference between experimental probability and theoretical probability. And this is how you answer a question like this. You find the relative frequency. First thing you do, you add the frequencies together. After that, you take the frequency and divide it on the total number of the frequencies to get the relative frequency. And then you use the relative frequency as a probability for this event and multiply it by any number they gave you in the question, or they give you in the question, to find number of people or a higher number of people, probability of the event happening. And this is how you answer a question like this. Thank you very much for watching. See you next time.